So switching gears a little bit, so the recursive formula, remember we talked about the recursive, that is not the formulas on your formula sheet. Recursive formula depends on the previous term. So if we are adding 5 each time, it would say a sub n minus 1 plus 5. It would say whatever the common difference is. You must always define your first term when you're writing a recursive formula, okay? So for number 6, they're telling us that a sub 9 is 55 and a sub 14 is 100. And they just want us to write the first 4 terms of the arithmetic sequence. So, pretty much we know it's arithmetic, so we're going to go ahead and find the common difference, the same we did on the last problems. So I'm going to take my 100 minus my 55 over 14 minus 9. So we'll get 45 over 5, so my common difference is going to be 9. Alright, we are going to need the first term here, so we can find the first term just like we found it in the previous problem. So we're going to need to use that explicit formula to find the first term. So I always use the first one here. So a sub 9 is 55. We're trying to find a sub 1. Because we're using a sub 9, that's going to be 9 minus 1. And then the common difference is 9. So we're going to have 55 plus 55 equals a sub 1 plus 8 times 9, so 72. So if we subtract over 72, a sub 1 is going to be negative 17. Okay, it says write the first 4 terms. So the first term we know now is negative 17. And we know the pattern here. Because the common difference is 9, that means we're adding 9 each time. So if we do negative 17 plus 9, we're going to get negative 8. Add another 9, we get 1. Add another 9, we get 10. Okay, so we are adding 9 each time here. So this would be the first 4 terms. So it doesn't tell you to write the recursive formula, but I want to take it a little bit further and write that. So if you were going to write the recursive formula, you have to write the first term. So we know that's negative 17. And then to write the recursive, we're going to say a sub n. Previous term is represented by a sub n minus 1. And then each time you're adding 9. So it would just look like that with adding 9. So this would be your recursive formula. And if you look back over here at the recursive, this means previous term plus common difference. Well, the common difference was 9, so previous term plus 9. Alright. So those were all talking about sequences. Now we're going to move on to sums or series. Remember, sums and series go together. So there's 2 different formulas here. If you look at the formula sheet on arithmetic, they give you this n over 2 times a sub 1 plus a sub n. That's the formula you would be given. So sometimes I work with this other formula, but I found that since people have formula in their formula sheet, they don't want to memorize anything. For some reason, math people think, oh, you don't need to memorize. So we're just going to ignore this other formula. It's the same thing as this. It's just another way to get it. And I'm going to just use the formula that is on the formula sheet that you would be given. And we will go from there with all these problems. This is the time to memorize a different formula. Okay? So we're not going to derive this or anything. We're just going to use that formula. So once again, that formula is under arithmetic because that's what we're working with today. And it says S, which stands for sum. And it's n over 2 times a sub 1 plus a sub n. Okay? So, taking a look at number 7. It says, first that we want to use this with a formula and not just type in the calculator, so not with the sigma that we talked about the previous day. So we want to find S sub 50. So that means the sum sub 50 represents the sum of the first 50 positive odd integers. Okay, what does that mean? So, a positive odd integer. So, what is the first positive number that is odd is 1. Then the next odd number is 3. Next odd number is 5. Next odd number is 7. Next odd number is 9. And that would keep going on all the way until you got to the 50th term. Okay? So, it says that we want to find the sum of the first 50 positive odd integers. So because we're finding the sum, let's go ahead and look at our formula. We're going to have to use in the end. So we're going to be using the formula S sub 50. Well, let's just write the general formula first. So S sub n equals n over 2 times a sub 1 plus a sub n. That's the formula that we're going to be using. Now we are working with 50 here, so we're going to be doing S sub 50. N is 50. A sub 1 plus a sub 50. That's what we're going to need. Okay? Alright, so things that we need. So in this formula, look at what we need here. We're trying to find S sub 50. We have 50 divided by 2. A sub 1 is the first thing that we need. Well, we just figured that out. A sub 1 is just going to be 1 here. So let's go ahead and fill that in. Alright, A sub 50, so that means the 50th term. So we would have to write this out until we had the 50th number here. Well, we don't really want to do that. So what we're going to do is we're going to use our formula that we have, the explicit formula, just for the sequence. That way we don't have to figure that out. So, we'll come back to this over here. We want to use A sub n equals A sub 1 plus n minus 1d. I want to find A sub 50. I know that A sub 1 is 1. I want to find the 50th term, so n is 50. And the common difference, well, we haven't figured out that yet, but if we look at our pattern here, they're adding 2 each time, so our common difference is going to be 2. So A sub 50 is going to be 1 plus 49 times 2. So A sub 50 is going to be 99. Well, that's the number we needed over here. So now we're going to go back into our sum formula and we're going to plug in 99. Now we just have to compute this. So we'll have 25 times 100. So our sum of 50 is going to be 2,500. And there's the sum that we wanted. Okay, so when we start doing these sums, a lot of times you're going to have to use 2 different formulas. So keep that in mind. The main formula that we wanted to use was the sum here. But a lot of times you're going to have to use just the sequence formula too, because you're going to be missing some part of this formula. But at the end of the day, you want to find the sum, so this 2,500 was our final answer there. Okay. So let's take a look at number 8. Okay, so for number 8, we're trying to find S sub 20, so we're trying to find the sum again. Given that A sub 6 is 85 and A sub 11 is 125. Okay, so let's just go ahead and write down the formula we're going to need. So we're going to be using S sub n, if you want to take a look at the formula sheet, equals n over 2 times A sub 1 plus A sub n, because we're trying to find the sum of 20. So specifically, we're trying to do S sub 20. So that means n is 20. We need A sub 1 and we need A sub n. Right now, we don't have either of those things, A sub 1 or A sub n. So we're going to do this like we did the problems earlier today. So we're going to find the common difference first. And to find the common difference, I'm going to do 125 minus the 85. And then 11 minus 6. So that will give us 8. Figure that out. So the common difference here is going to be 8. Well, no, there's no common difference here, so we're going to have to keep going. So normally after the common difference, we would find the first term. Well, we do need the first term. So we're going to find the first term. And remember, to get the first term, we would use that explicit formula from the formula sheet. Okay, and I'm just going to pick the first one. You could pick either one. We know A sub 6 is 85. So I'm going to put 85 equals, we do not know A sub 1. Because that was A sub 6, I'm going to use 6 for n. And we just figured out the common difference was 8. So we're going to have 85 equals A sub 1 plus 5 times 8. So if we subtract over that 40, our A sub 1 is going to be 45. Alright, let's go ahead and fill that in over here. So a sub 1 we know is 45. One other thing I'm going to fix on here, because this is 20, we're really trying to find a sub 20 here. Well, unfortunately, we do not know a sub 20. So we're going to do the same kind of thing. To get a sub 20, we're going to use our explicit formula. Okay, we're going to fill in what we know. We're trying to find a sub 20. We just figured out a sub 1 is 45. N will be 20 here because it's the 20th term, and we know the common difference is going to be 8. So it's going to have 45 plus 19 times 8, and if you calculate that, it'll give you 197. So now we know a sub 20 is 197. So if you calculate this, we'll have 45 plus 197 and then times 10. And you should get, for your sum of 20, 2,420, which will be your final answer there. So we had a lot going on there. So let me just kind of recap. We were trying to find the sum. So in general, this was the main formula that we were trying to work with. This n over 2 times a sub 1 plus a sub n. Because we were doing 20, we knew this was 20. But we didn't know a sub 1 and we didn't know a sub 20. Before we could even get either one of these, you had to figure out the common difference by doing your subtraction method. And then I figured out a sub 1 by using my explicit formula. Got that as 45, but then we had to use that explicit formula again so we could figure out a sub 20. Okay, so there were lots of, we didn't know any of these parts here, so we had to go on the side and use what we knew about sequences so we could figure out the series or the sum.